So, you're looking to get serious about AI and machine learning, right? Well, you've probably wondered about all the math that's humming away under the hood. In this explainer, we're going to break down exactly what you need to know and give you a complete roadmap to get you there. But let's just address the elephant in the room right away. With all these incredible tools like PyTorch and TensorFlow that do so much of the heavy lifting for us, can you actually make it in this field without getting deep into the math? It's a huge question. And this really lays it out perfectly. On the left, without the math, you're kind of flying blind. You're just guessing at fixes, fumbling in the dark when your model breaks. But look at the right. With that math foundation, you're not just a user, you're a creator. You can tune models with precision and actually understand why they behave the way they do. It's the difference between following a recipe and truly being a chef. Okay, so here's our game plan. First, we'll talk about why this stuff is so important. Then we'll dive into the three big pillars: statistics, linear algebra, and calculus. And to wrap it all up, we'll give you a super practical, step-by-step learning roadmap that you can literally start on today.
All right, first up, why the math matters. The big idea here, as you can see, is about getting past that frustrating guesswork phase.
Look, it's true you can get a model up and running without solving equations by hand, but things will go wrong. And this quote really hits the nail on the head. Math is the language of machine learning. When your model isn't working, knowing the math is like having a diagnostic toolkit. Without it, you're just staring at a black box.
Which brings us to our first pillar, statistics. This is all about getting a feel for your data, the very stuff your models are built on, and knowing which tools or algorithms to use.
You know, having a good grip on statistics is what helps you look at a data set and say, okay, this is the right kind of algorithm for this problem. It helps you listen to what your data is trying to tell you. And when it comes to tuning hyperparameters, it's a total game changer because you actually understand what all those little knobs and dials are doing to your model.
So here are the greatest hits you need to focus on. Understanding things like probability distributions, the classic bell curve, is fundamental. But what's really cool is something like Bayes' theorem. It sounds complicated, but it's really just the formal, mathematical way of updating what you believe when you get new information, which is pretty much exactly what a machine learning model does every time it sees a new piece of data.
Let's move on to our second pillar, linear algebra. If statistics helps you understand the story on your data, then linear algebra is the language you use to actually tell that story to a machine. Think about it. A computer doesn't see a cat in a photo or understand a sentence. It sees numbers, lots and lots of numbers. Linear algebra is simply the super efficient system we've developed for organizing all that data into neat packages called vectors, matrices, and tensors, so a computer can work with it. It's the bedrock of data representation in all of AI.
So what do you need to know?
Well, you definitely need to get comfortable with the basics, like vectors and matrices. But the real magic happens when you understand concepts like eigenvectors. You can think of them as the hidden skeleton of your data. They reveal the most important directions and patterns. They're the secret sauce behind powerful techniques like PCA, which lets you shrink down massive data sets without losing the most critical information. And that brings us to our third and final pillar, calculus. If linear algebra is the language of data, you can think of calculus as the engine that actually drives the learning process itself.
This right here is how the learning in machine learning actually happens. We use calculus to figure out, tiny step by tiny step, how to adjust the model's internal knobs to make it just a little bit better, a little less wrong. It's the whole science of optimization, and it's powered by this famous algorithm called gradient descent, which is just a fancy way of saying, find the bottom of the hill where the error is lowest.
Now, you don't need to be a calculus whiz, but you have to get the core ideas. You need to understand what a derivative is, because that's what tells the model which direction is downhill towards a better answer. And you absolutely, 100% need to understand the chain rule. It's the powerhouse behind backpropagation. It lets a neural network trace an error all the way back through its layers to see exactly which part was responsible and how to fix it. It's amazing. Okay, we've covered the what and the why. Now for the big question, how in the world do you actually learn all this stuff? Well, here is your learning roadmap, a clear, simple guide to get you there. And this is just a brilliant way to approach it. Please, don't start by just cracking open a dry textbook. Start at step 1. Build your intuition, see how these concepts work visually. Then, move to step 2 for a more formal, structured course. Step 3 is for patching any holes in your understanding. And finally, step 4 is where you connect it all to the real world with practical machine learning books.
And here's your toolkit, all laid out. For that aha moment of visual intuition, the YouTube channel 3 Blue 1 Brown is just legendary. For a structured course that gets you coding, the Coursera specialization from Imperial College London is fantastic. Khan Academy is the absolute best for nailing down statistics, and then books like An Introduction to Statistical Learning are where you see how all these pieces come together in practice.
So there you have it. We've laid out the why, the what, and the how. You have the complete roadmap. You have the best resources right at your fingertips. The only real question left is the one that matters most. What's the first step you're going to take?